Thank you.
Okay. Let me see what I'm going to tell you. Let me see, does this work? Not yet. Yes, it works. Okay. First of all, my story is going to be about the relevance of nature in our architecture. For starters, our name of our office, Natrufied, is made out of two parts of words, namely natrufied and petrified wood. So if you glue them together, you get a sort of natrufied combination. What it means is that we would like to make the nature appear permanently in our buildings, and this is possible in various ways. First of all, I would like to take you back a few thousand years ago, when nature was roughly looking like this. A lot of variety. You could have forests, deserts, mountains, different climates, and people would start living in that and would try to make from local products local shelters. So in a wood area, you have wooden houses, maybe with grass roofs. In a desert, they would make tents, and in mountains, you would have stone and can use even the mountains for shelter. This is how our cities look at the moment. This is an image from one of our former colleagues in the office. He moved to Tokyo a few years ago, and he posted this image on Facebook and said, "Happy to be home." And I really was wondering what he was meaning, because everything I saw was a giant pile of concrete. Actually, I cannot find one tree in this image, and still he would say, "Happy to be home." This is how we regard our world at the moment. Concrete blocks, big holes to do your work in. We really lost completely the contact with nature. But this is not how we were made to work and to function. We're outdoor people. We were created outdoor by whomever, I don't know, but by somebody put us here in the outdoors, and we're fit for that. So we have to go back outside again and learn to understand what the outdoor brings. Usually a lot of good, sometimes maybe rain. That's the moment you need some shelter, but most of the time we're happy outside. And it's important to reconnect to this nature again, because that's also one of the reasons why we are demolishing nature so dramatically, because we have no link to it. If we think that our home is a pile of concrete put together, we don't care about the nature, and we don't understand that it's important for our food, for our climate, to have nature so that we can live in balance with that. We need our resources, we need birds and insects to make our food. If we start killing all of that, soon we won't have nothing left. So this is really important. Then there's some awareness among architects, among others, on we should do something about that. So we talk about sustainability now for a little while among architects. Yeah, we really should make sustainable buildings. Okay, what does that bring us? This is an example in Amsterdam, big office building that is one of the most sustainable buildings in Amsterdam, apparently. There are solar panels on the roof, and it has a big heat pump energy supplier, and with that it generates its own energy. But the building is still mainly made out of glass. The sun shines onto it, and you have to dramatically cool it in the summer. You really have to put in a lot of heat in the winter to make it comfortable. So yes, it provides its own energy, but it's still incredibly energy inefficient. It really uses a lot of energy. Even if you generate it sustainable, you could give this sustainable energy to other buildings or cars or whatever you want to use it for. What is important is that we start making buildings that use little energy, and the little energy that you need, you should get from sustainable resources. So that's the take that we have on it. Then the other level is where we talked about it with Onat a little bit as well before. Where do your building materials come from? If you find bio-based materials, so everything that Mother Nature grows itself, so it can be wood, it can be bamboo, it can be thatched, all kinds of natural grown products, you can make perfect buildings out of that. If you grow those just by itself, you can always recycle them easily into nature, back into nature, if you don't need them anymore. And that's really the life cycle view on a building. We don't build for eternity. We're not making colosseums in Rome that will last 2,000 years. Our buildings maybe are there for 30, 50 years, then they get demolished, and we have to be able to recycle them in a sensible way. Then the third take on sustainable building is produce as little CO2 as possible in our in building buildings. There are a lot of other areas in our economy that should contribute on producing less CO2, but buildings is really one of them. Wood and bamboo as well. Basically, they're the only two construction materials that have a positive take on CO2. So actually they store CO2, and with that we make buildings with a positive CO2 addition to our economy. All the other products, so if it's concrete or steel, aluminium, all these produce a lot of CO2. So that's another good reason to build with wood, bio-based materials in a bit broader scope. So what happens if we start building with wood? To be able to build with wood, you have to have a long-term vision on where your products come from. So a forest basically grows in 50 years. After 50 years, you can take out a tree out of the forest and start making construction materials out of that. Nature is a circular process. So if we would just look at a forest, a little tree starts growing somewhere, it turns into a big tree. At a certain moment, maybe after 50 or 100 years, the tree is fully grown. And at a certain moment, it loses its strength. There's a storm coming or a wildfire, the tree is tumbled over, it starts rotting again and will provide for new growth material for next trees or plants. So it's a circle. It's not that a forest is a stationary thing of big trees. It's a dynamic thing of trees coming and going. Now, before these trees are old and start tumbling over, I come along with my chainsaw and take out this tree out of the forest. With that, I make space in the forest for a new tree to grow. And in the meantime, I take the trunk of the tree and bring it to the wood factory, and they make building materials out of that. So basically what we do is we fit the cycle of the forest and the natural growth of the forest. We just take out the useful wood before it starts tumbling over and starts rotting again. In that way, the cycle of wood still remains, and we can still basically build buildings for free. Now, there's also an economic incentive into this. If we make forest and somebody is paying for the wood to make buildings out of it, there's an incentive for people to let the forest grow. Imagine you own a piece of forest and you want to earn money to provide food for your family. If Boris comes along and says, I would like to buy a tree from you and I give you money to feed your family, that's an incentive for this person to keep the forest. Now imagine I'm not coming there, he's still hungry, so he decides, okay, I take off all the trees out of my forest, I grow grass, I put cows in it, and that provides me with milk and meat. Both products you can sell to the US or to anywhere in Europe happily. So in that case, he can also provide for his family. But we lost all our forest, and instead of having land that takes out CO2 from the sky, we put cows in that actually produce a lot of CO2. So for reducing the CO2, it's really bad to build not with wood, because our alternative will be more CO2 producing cows. Now I have a special link to Sweden, so this is one particular example just to show you a little bit of what is going on. Sweden has 40 million hectares of forest, and that's about 10 times the Netherlands. And from only the growth of the trees every year, you can make 5 million houses. So every year you could make 5 million houses just by maintaining the forest that they have. And Sweden has a sustainable wood industry where every tree that they take out every year, they plant a new tree, and with that the forest maintains its own size. Actually, in the past 40 years, sorry, the amount of forest grew in Sweden and in all of Scandinavia because it's an industry and because it's an economic incentive for people to make forests. It's a nice thing. It takes a lot of time, but you don't have to do a lot of things for it. So now we got our wood from the sawing mill. We used to, in many countries in the world, used to be able to build smaller houses out of wood. In Scandinavia, in the Alp countries, there's a lot of tradition among European countries building in small scale in wood. Now, basically what is going on in the Netherlands, and I see it in other countries, in England and in Germany, in the up countries as well, especially also in Scandinavia, we're trying to make a next step into scale. And it's a lot of experimentation. We have to find out how it works. But the first examples are on its way, where we built 6-7 stories at the moment, and really make it into an industrial product. As I said, there's a lot of experimentation, so there are different principles. You could have a column and beam structure. You could have massive walls called CLT to make your walls and to make your ceilings. Integrate all the stuff that you need in there, and you have an efficient product. The nice thing about wood is that it is really light, as Sander mentioned before, so it's easy to transport, and with that it's also a lot easier to make pre-mountable units, and with that also a gain in building time. Maybe not too interesting for you as a student at the moment, but I'm sure later on in your profession you realize that your building time is an important thing. If you imagine you have to build in a city center, and your building is done after 4 weeks instead of after 12 months, the amount of hassle on a building plot, on a complicated building plot in a city center, is for the city really important. If you block your street for 4 weeks, it's a lot less hassle than if you block a street for 12 months for people to deal with. At the moment, there's also a run for the highest wood building in the world. So at the moment, if I'm right, there's a building in Norway on the right bottom. You see an image, 84 meters high, I say from the top of my head. That's the highest building at the moment. In the Netherlands, they're building a 74-meter high building at the moment, which is constructed as we speak. In Vancouver, in Canada, they're building 2 wood buildings that are close to 100 meters, but not finished. So they haven't won the race yet. That shows a little bit the urge and the experimentation on making wood accessible for big buildings. Not that it's important to build high towers, but it's important to investigate how you can build in that way, because it also shows a certain importance. So if you look at New York, 100 years ago, they were building skyscrapers, not because New York was full, it was also pretty full, but it was mainly because it was possible with the invention of concrete and the combination with steel, the invention of elevators. Suddenly we were able to make very high towers, 100, 200 meters high. And it showed the importance of building in concrete, and with that, the power of money. So we used to have churches with high towers. In the many hundred years ago, they showed the importance in villages of God in our lives. Then in Italy, maybe 500, 600 years ago, the high towers got on buildings of the government. So the central town hall would get a tower. And then 100 years ago, we had the power of money showing in Manhattan, how important that was. And now we have our high wood building. So I think that is also a point in time to show that we have to build with other materials. Now, there are two issues that require extra attention in building with wood. First, that is fire. Of course, wood is a building material that is able to burn. But if you use CLT, these thick concrete, there is these thick wooden walls that are glued together. They can be 15, 20, 30 centimeters thick. If a fire would occur, the walls would only burn to the outside, so the building wouldn't be able to collapse, because the black part on the outside makes a protective layer for the fire not to be able to go into the wood further. Maybe a bit a technical thing, but important for later to understand. Also, of course, everybody, I hope, try to make once a little campfire somewhere. You never try to do this with big piles of wood. You really need very dry wood, very small pieces, and with that, maybe you're able to make a fire. So that would mean that if you really use thick walls in wood, it's almost impossible to set fire to things like that. Then there's a thing for how we perceive health inside of a building. If you make wood structures, you're able to make a damp, open construction. So imagine we make our concrete and stone buildings that we did so far. We don't want any moist in these structures, because then it starts rotting and it cannot ventilate because it's too dense. With the wood, it's an open structure and it can ventilate the moist out of a room or out of a building. So as we sit now in our buildings, we produce this moist sweat and all these things that has to go somewhere. But basically what we do in concrete buildings is we make sure that the moist is not going out. You can compare it with putting a plastic bag over your head and try to breathe. This is not a healthy matter, and it gets really moist inside. You have to be able to get rid of the moist. Now we do that with a lot of ventilation machines. We need gigantic ducts for that to get rid of this bad air. But all wood structures can take care of that a lot easier. When I talk about wood, there's a lot of layers that you can integrate. So there's the main structure, there's the wall structure, there's the wall cladding, there's the window frames, the outside cladding. So there's all kinds of different wood pieces to use in your building. So to sum up this wood thing, 4 important things. If we build with wood, it is an incentive for people that own forests to maintain the forest, so they keep providing us with wood. Wood is a circular building product that reduces CO2 instead of adding it. There's really a modular building method, being able to not build everything on site, but organize your building in a factory, just bring it to the site and assemble it in a quick way. And the nice thing is, if we build more forest because we need the wood, you have 50 years of taking a hike in the forest for free. Okay, now some examples. I prepared 6 examples from our own work in various sizes and in various stages.
Boris,
yes.
Boris,
yes.
Can I just interrupt? Maybe, of course, if you're okay with it, maybe they have some questions about it. If it's okay for you?
It would be possible, but can we do that all at the
Later,
end?
of course, of
So,
course.
This was basically my introduction on building with wood. I'm sure they have a lot of questions about it, at least that's what I hope. But I would also like to show them some examples in first before they start asking questions.
Right.
So that they understand what we're doing with it, and maybe that answers already some questions. Is that okay?
Perfect. Yeah, perfect.
Okay, then I go on. Okay. First of all, I'm involved in a project that's called Onat, and that is a combination of architecture and nature. That's an architecture festival in Sweden, in a big nature area. It's called Höga Kusten, and that's used for hiking in nature. Swedish people are outside people much more than Dutch people are. So they go out often and hike in nature, and this is their most beautiful area along the east coast of Sweden. There are hiking paths, and this architecture festival adds so far nine hiking shelters along this path, and basically a group of architects teamed up with a local guy that is running a touristic center in this area. And we invited every year about 20 students to build 3 shelters in nature. So you see a map here of where the current 9 are, and every year we'll build 3 more. So 20 students come in, and there we go to the 3 different sites. They're typical sites, one at a water site, one on top of a mountain, and one in the middle of the forest. And the group is divided in 3, and every student can come up with a concept and present the concept to the group. So that would mean you have 24 hours to do this, to come up with a concept and make it presentable. And that means that by the end of the day, we have 20 concepts for 3 locations. And we turn it in a competition, so all the students can vote on all the designs that are there, and 3 designs that get the most votes will get built in the next 3 weeks by the same group. So basically it's an open competition for the students to get their own ideas built. So first of all, it's an individual thing for 24 hours. Then the 3 designs get chosen, and you work in a group of, let's say, 6-7 people developing this scheme, which you present also to the tutors, to the architects, and to the other students as well. And within about a day or 4, the design has to be developed in such a way that you actually can start constructing it. So a wood company is one of the main sponsors. They bring a lot of wood to the building sites, and from there you can start constructing in about 3 weeks your design. That could lead to hilarious things like a tree house that was designed for the top of the mountain, but was not able to get there. So we hired a helicopter to deliver this product on the right spot. Then it was put into the tree, and this tree house occurred. Another one was this floating shelter in the woods that was also not touching any ground and just had cables to the trees around it, and basically it's like one big rocking platform where you can find shelter as well. This was another one on top of the mountain, overlooking the whole area, but you never know where the wind is coming from. And there are beautiful views to all kinds of areas. So this is a shelter where you can close one side just by tipping the point. So you see that one of the 2 points now up, you can pull that down and then the other side is up. So wherever the wind comes from, you put that down and you have a view towards the other side. This is a nice wooden shelter integrated on the seaside, where you can find some protection and have the view at the same time. I could show all nine of them. They're all at similar qualities. It's really an exciting thing to do with students. They invest a lot of their physical energies in it because you have to build it yourself in the end. And it's a great experience for students to learn to realize their dreams and how much energy and effort it takes as well. We had some people from Turkey also being involved in it. Basically, it's open every year for students, mainly from Scandinavia, because that's the easiest to get there, but you can apply also from further abroad. But only about 20 get selected in the end to join. This year, the big Swedish Architecture Prize for architecture was given to this Onat Festival because they liked the results, but also the initiative so much. So we beat all the real buildings with this initiative. I'm very proud of that. Then we move to Bergen, my hometown. It's, I think, a beautiful area, a coastal area close to the sea with a lot of forest and dunes. And we have a beautiful building plot that is a little bit hidden in the landscape. We designed a house with various views. It's really about living in nature, but with all the luxury that you would need. This is the site, a big house among the trees with a very open floor plan, windows from all sides, and various areas to live, sit, dine, cook, eat, and watch television by. Underneath there is a basement with all the bedrooms, which is closed from one side with a patio that brings in limited light and open views from the outside over the wooded area. This is the one of the design renders that we make. Big cantilevers will keep the sun out in the summer months, so the glassy floor plan doesn't heat up too much. In winter, the sun is lower and it will bring in a lot of light in the winter, but not heat up the building too much. This is during construction. You see the open ground floor with only the wood structure and the basement in the ground with the bedrooms underneath. It's a bit pixely, but still, I would say, visible. The central gate, car park, and at the right side, integrated in the landscape, and the house in the back. The house with the big cantilever protected for rain and wind as well. Interior with a big open fireplace, and also see the all the windows around that bring in the nature really into your experience. A lot of natural products, so we not only use wood and wood-related materials, but try also to find local natural stone that comes from Belgium that we use in the walls. And here you can see, for instance, the bedroom in the basement, still having a view outside into nature, and an image of the bathroom with the skylight patio next to it, bringing in light. Another project only in design stage here in our town at the sea. It's called Blooming Beach, a beach resort. It can be pretty rough on the beach in autumn and winter time. We really have big storms bringing in the water completely until the dunes. So dealing with the wind is really an issue. If you look at images from the beach, you see that the wind also shapes nature by taking and adding material at certain points. And basically, we wanted to make a design that did a similar thing. So we did all kinds of sand tests with a big wind blower. We put a big pile of sand in front or behind some volumes. You see here some experiments of different shapes, maybe a triangular or a more rounded or a more square building, and looked how the sand would react to the building, where it would take away sand and where it would add sand. And with that conclusion, we found the right floor plan and the right section where the sand would be added and where we wanted, and would be taken away where we wanted it to be taken away. That led to a design for the beach pavilion in a certain shape, so that the sand in front of the beach pavilion wouldn't stay there because then it would block the view, but would add the sand behind the building where the dunes are, and that's where we want the sand to be, so the dunes stay as strong as we want. The floor plan to the front is really open. The back has all the facilities for a beach restaurant. On top there's a big terrace, and here you can see a little bit of the shape for how it reacts on the sand. This is the final proposal. So this sort of natural shape made the sand make the dunes stronger, because that was needed so that we wouldn't have to take away the building, because as you probably understand, the dunes are essential for our safety, because most of our country is below sea level, and the dunes basically keep the sea out. So if the dunes get too low, the water will come into the country, and we should make the buildings along the sea adding to the strength of the dunes rather than take it away. Okay, a few more. Regen villages. This is in a typical Dutch landscape, an open, flat area where farmers would make our crops and our food next to a new town area where we make more row houses for people to live. And basically this this design tries to integrate these two parts rather than disconnecting them. So we want people to be more involved in creating their own food next to their house. So they really understand again where food comes from. So vegetables don't grow in supermarkets. But nobody knows anymore, because nobody knows where they're coming from. Just what they see is that they are there in the supermarket, and basically don't have to care where they're coming from. That's also why it's so easy just to throw away the food after you don't need it anymore, because it just looks like it comes out of nowhere, and that's not true. There goes a lot of effort and energy in, but also it's an attack on nature, and we should be careful with that. So we made a whole scheme, not only for houses and roads and maybe a garden, but also for the rest of the food. And people that are going to live there, this is designed for 200 houses. They could be involved in making their own food. If they want to do that, they can take care of the crops or take care of the sheep or the cows that are in there. But if you don't really care, it's still around you, and it's taken care of by, it's organized by a central organization. And if you're a person like me that doesn't really like to garden, that's fine as well. So you pay for your own food. It's only grown around you and will be delivered when it's ready. But it really invites people to be part of their own food production. So this area is really about food, farming, fruit trees, local community, housing, parking, all the things together. This is a scheme that we make with 7 different areas for 7 different kinds of food production in the shape of a tree for these 200 houses that are integrated in there. This is all the wooden houses that also react on work with the sun in the winter and the summer. They generate a lot of their own energy in an efficient way. So part of the greenery is done in houses with a local greenhouse. So the greenhouse provides warmth in the winter as well, because the sun can heat up the area, and you can use it year round to make your own food for your own production. But there's also central communities, more greenhouses and open fields, food forests where trees grow, but it's also a central community for these 200 houses to work together and come together. There's a central facility, it's called aquaponics. There really the groceries are produced in a super efficient way. We have a lot of greenhouses in Holland, and basically we just take these techniques, these efficient growing techniques into the neighborhoods where having fishes, they provide food for the groceries, and the groceries clean the water for the fishes, and in that way you have again an important cycle of nature sort of brought into your own community. Another project, it's called De Warren in Amsterdam, a apartment building for 36 apartments. This is how the area looks now at the moment at the edge of Rotterdam. I think Sander is sort of living in the back of the area somewhere there. We just make our own land. Everything you see on this picture wasn't there 20 years ago. It was just water. And we just made new land next to Amsterdam in the big lake called the IJsselmeer. We just take sand from the lake and put it here, and then we just make new neighborhoods. This is the group of about 60 people that are going to live there in these 36 apartments, all young people and 20, early 30. They decided that they want to live together in a communal building where they share a lot of facilities. So the essence of the building is you have a small apartment for yourself, but you have a lot of communal functions where you can share facilities that are easy to share. We had a whole design process with these 60 people. Two things are really important, a super sustainable building, as well as, let's say, this investigating how you can live together in a community and have enough privacy for yourself. So we did a lot of experiments on that. Basically, about 1/4 of the whole building is collective facilities. Normally would organize them on the ground floor so it's easy accessible, and then you have all the apartments on top. We try to much more mix this whole area, so all the green blocks that you see are collective areas. The purple things you see here is a communal kitchen and other communal facilities which are there every floor. And then there is a nature inclusive facade on the outside that literally means we bring in nature into the city. This is also an important thing for the municipality that they're trying to do, so that really fits with our idea of people exposing to nature so they understand nature better again. And then we put greenhouses on top of the roof, and of course a lot of solar panels and other things for making our own energy. We try to make a building that is as much out of wood as possible. There's a lot of acoustic requirements for that, so you always need a certain amount of concrete. Of course, we make our the basement of each building we just make out of concrete. It really is nonsense to try to make that out of wood. So there's still a lot of concrete in the building, but also we try to use wood where we are able to use wood in a sensible way. This is the whole sustainable scheme. I skipped the details, but really try to integrate everything. It's a building that produces more energy than it needs by using all the techniques that are available at the moment, including a rainproof program required by the municipality, where we make sure our own rain gets harvested and not just flushed into the sewage. And we made rain buffers on the roof and in the garden to feed all the plants that are on the roof and in the facade for this building. So even in dry periods in the summer, there's a big rain buffer that can water our plants automatically. Then another thing that we added is we try to recycle materials where it's sensible. So there is a company that made a harvest map from building materials that are available from demolished buildings. So if a company demolishes a building and finds good and recyclable materials, they bring it to a storage facility, and it gets announced on this harvest map. And with that, you can find the building materials that you would need and try to use that in your designs. The image you see on the left bottom is pieces of wood that we recycled from, in Dutch it's called meerpalen. So it's the poles that you dock the boats on in the water. So it's the strongest wood that is available in the world, because it has to stay in the water, and water and wood is normally not a good combination. These poles are not necessary anymore, so they got taken out, but it's impossible to burn them in the the factories where we get rid of our rubbish. So they didn't know what to do with it, and we are now making the facade of this building out of this material. So this is an image on the inside. We're almost starting with the construction. The documents will be signed with the contractor this week, and then the construction really starts. This is one of the communal spaces of the building. This is the outside. So here you see the big communal space with a big stair going up. You can see the big stair here, connecting all the stories together. So if you leave your apartment, everybody will end up at this central stair, and everybody will move through this central area, meet each other, and really try to live together. All the green stuff is the nature inclusive facade that we made out of the recycled wood that gets fed by the rainwater harvesting. It also includes the balconies. So your balcony is really in between all the green stuff, where we also make space for birds and other insects to find their spaces, because they have to live in the city as well. Of course, the roof terrace and the greenhouse here in the back, and all the solar panels on the roof for your building. Okay, one more, if you can stay with me. Almost done. A theater building in Paris. There's a theater building in Paris that's called Cabaret Sauvage. That's really a tented structure. It makes too much noise, and they had to get rid of it because of the municipality. It's a circular building. What we did is we added another circle, so there are 3 asymmetrical circles into each other, with all the functions that we needed. If you guys ever try to design with a circle, you'll find out that it's really complicated to make a clear entrance in a circle, because it's basically a finished line that you cannot penetrate. So what we did is we added a sort of little skirt on the outside at the entrance, just like Marilyn Monroe's famous scene from the movie, where the skirt is sort of blew up, and with that the entrance is provided. The whole structure is made out of wood for the theater, because it has to be a prefabricated building that has to be able to move also after 5 or 10 years if the municipality decides not to continue with the permit. The most important thing is that this building keeps the noise inside and not have it spread to the surroundings. So this was the design that we made, with the little skirt providing, let's say, the central entrance in the circular building. Then a lot of engineering was going on. All the products were prefabricated in the Netherlands and Belgium, shipped in 2 big ships to the site, and assembled together in 3 weeks. So in 3 weeks, the whole building was done on site. Here you see some images of the building site, all the pre-made materials assembled on site. Here's the little skirt on its way, and this is the final product and the inside. Okay, I'm done. Thank you. Onat, are you awake?
Yes, exactly. I was just posting because that was really inspirational. I love the part with the Marilyn Monroe, of course, but Actually, the
So,
thing is,
and our client as well.
so, but the most important thing, one of my students was, I think in this Onat. It's a wonderful thing, and when I've seen it, I think the result. I don't care the result like these kind of things, but at the same time, it was amazing. I'm amazed. It's a really hard job, but also they just constructed it. When you give them actually the material and the things, and if there's an initiative, I think always young architects or students are just much more willing to do more creative, more brave things. So I really like it. So that's why I was just actually the first time that I shared Onat, one of my students just applied for it, and I suggest all of you to if for the next time. I hope I don't know how it will end with maybe the vaccine will solve all the things that we're just facing with right now. But in the future, if you have a chance, please just apply for it. Apply for it, because but also my students just thanked me after the Onat, because he just said, okay, I was stuck in a limited career, like working in an office or something like this. But then I start to understand that the creative process, maybe it was much more. I think it's maybe it's a fault of us. I was also the instructor, but he told me that I learned more from the university. So it was not that nice.
You need them both.
Yeah, but it was not that nice at the moment. But now I understand. I understand.
Yeah.
It was,
no, he was a great guy. I remember he was there last year, and he was also in the design, sort of stuck in the beginning, and really wondered, what the fuck am I doing here? And then suddenly he got integrated in this team, and they started building, and it was really the best time of his life. Being so much one-to-one involved in making your own architecture, having to solve your own problems, your own details. Suddenly details are not made to put on drawing, but you really actually have to think on how you put things together. And I think that's such a mind opener for students and young architects to really understand that part of our profession. So making concepts and making designs is super important, but you have to have a vision on how you can put it together as well.
And it actually, he was just mentioning about the encouragement that because he was a little bit after graduation, like in the Jamie Cullum song. After that, it's kind of after you just leave the comfort zone, because in the university or something else, then when you start, you just say, okay, first I have to finish this. But for the future, actually, they think that there are limited options. But these kind of initiatives, I think, just expanding the many things. So it's also really important. I really suggest if there's going to happen in the future, I think you should all apply for it. And I hope you will be.
If I may add, Onat, it's important that we have this in many countries. So I think I'm thinking on how can I start this in Holland. You should be thinking on how to start it in Turkey, because we can make it part of our projects as well. You know, if you make a beautiful park, there's always space for 2 pavilions. Get it built by students. You know, it is such a contribute sort of extra contribute to your design as well, and it's a great opportunity for students. So let's think about that as well.
Of course, and it would be really, because now I'm maybe you know it, because of the quarantine and the things that's happening here. I'm living in a village, and it's close to the seaside. But the thing is, we cannot go out. But at the same time, it's a little bit, and also the northern part, the western part of the area that I'm living now, it's already they define it the natural side. So you cannot do anything. But the people are just people need. For vegetation or something like this, they need barns, so they build barns. But what they know or what they suggest, because they always act. For example, one neighbor just do this, the other one do the same, and if the first example was terrible, then the whole suburb area is getting terrible. So it can also lead some people that there are many possibilities, and the most important thing is the students, architectural students, can have a really important role in this to give direction to the people who need technical people, but creative people, not like the things. So they can use, because they use wood, but they don't know how, they don't know the building technology, or they don't know how to just combine it with their things. So they always use the things that's trying to, they make it more expensive, but they make it more terrible than the things. So I will look and search for it to do it in Izmir, in Turkey. You can be sure we can find some people who will be sponsored for it, because they will love it, because they're also expanding. They're also trying to do research, but they always just finance or being sponsors for just things that for the talks and the things. But I think this is kind of a benefit for the people who will be sponsored, and also for the students and for the young people, with which will affect the local people too. So I think I will just look for it and search for it, and I will let you know. If you can send me something, I can just share it with some some companies.
I'll send a new link, because there's a new date for next year. I mean, depending on Corona, but I have good hopes that in the summer it's all behind us and we can act a little bit more normal. So there's a new date set already in June. So I'll send you some link that you can share with your students.
Great. Perfect. So, Jansu, Shevin, maybe you can just, do you have any questions? Any other?
Some questions. Yes.
So you don't need to be shy, actually. So
just throw them in.
Some of the participants actually wrote to us from the chat, so we can ask, or if they want, they can ask you the questions.
They can ask them, or you can ask them. That's all fine.
I can ask one if you want.
Sure.
Emre had a problem with his microphone, I think. So I'll ask the question. He asked that, do the wooden buildings you mentioned have a disadvantage against earthquakes compared to concrete buildings?
Do they have a disadvantage or an advantage?
Yes, disadvantage.
Disadvantage. So there are certain items that you have to be aware of. Spans of buildings are different. It's financially more efficient to make smaller spans than, let's say, we are used to do with concrete. So that's something you have to keep in mind. We need thicker walls to make them load bearing. So if a normal concrete wall would be maybe 20 centimeters, then we now need 25 centimeters. So that means that your net building surface gets a little bit smaller than with concrete buildings. These are things you have to be aware of. And financially, it's still more expensive to build with wood at the moment than with concrete. As I said, there's a big concrete lobby machine here in the Netherlands, but also in other countries. Because if we would start taxing our CO2 emissions, for instance, then it's easily solved to make wood much more competitive than concrete. But at the moment, wood is still more expensive to use, while it degenerates the CO2, so it takes on CO2 instead of producing CO2. The concrete buildings produce CO2, and as long as we are not aware of that this is an issue and it should be dealt with, also financially, then it's hard to start winning this battle. It's also a part of industry that is developing. So an early industry is not as efficient as a industry that is been there for 100 years. So that also is putting some pressure on the price of wood buildings. Nonetheless, we are able in the Netherlands and around us in other countries, we are able to make wooden buildings still pretty competitive in such a way that people are willing to pay for it. So in the end, we're talking about a few percent more building costs than let's say regular buildings. But people understand the issue and realize that they should invest this kind of extra money into their buildings if it's required from municipalities or it's project developers that want to show their sustainable interest, or it's private people that say, no, I want a healthy building and I want to have a sustainable building, that they all accept this extra investment. You understand that if a wooden building is 2 or 3 times more expensive than a concrete building, nobody would build a wooden building. So it's really about a little bit more expensive, so much that if you want to, you would be able to afford this.
Mm-hmm. Okay, thank you so much.
I received a question as well. You mentioned if you made the wood thick enough, you wouldn't have a problem with the fire situations, and they asked if there are any extra precautions against fire when building with wood, except for making it thick.
Basically, it's not necessary. So as I tried to explain, it's really hard to set fire to a solid wooden wall. You really need an incredible blowtorch to be able to do so. But what is most important for buildings in building regulations is that if there's a fire in a building, any building, a concrete building, steel building, or a wooden building, it is that it stays up for a certain amount of time, so that people who are inside of this building can flee in a safe way. You can imagine that if there's a building fire and the building collapses within 5 minutes and you're on the 20th story and you have to use the stair, it's impossible for you to get out safe. So therefore, we made regulations that a building of a certain proportion needs to stay up 60 minutes, 90 minutes, 120 minutes, so that you can safely get out of the building, or the fire department can get safely in and rescue you. This is the most important part of fire safety, and that's easily dealt with these wood walls that I try to explain, that get a sort of protective black layer on the outside, and then the wood cannot burn in any further than that. Also, if you look at, it's easiest explained, if you look at a forest fire anywhere in the world, if it's California or here in the Netherlands, if there has been a forest fire, there's always the tree trunks that stay up. So these thick tree trunks, maybe 0.5 meter thick, they're just black. The tree is dead, but the wood is still there, and the inside of the wood is still, let's say, wood color. It's not black. And this, these tree trunks stay up in the biggest heat of a wildfire and still don't burn. And that's exactly the technique that basically we take to the building site. As soon as you have this protective layer on the outside during a fire, it cannot get inside of this black area, and the building will stay up, so you can leave in a safe way.
Okay, thank you, Boris.
Is there any other questions before
we move to Sander?
I have a question, maybe, if it is okay for everyone.
Yes, of course.
First of all, thank you for all your presentation, the way that you approach architecture and sustainability very inspiring and interesting. Thank you.
Very welcome.
I have a question about a tree cycle, tree cutting and planting cycle. Of the presentation, you have said that we cut trees, but we also plant trees for wooden constructions. But I wonder if the tree growing takes so much time and so much water also, but the constructions are very fast, as you said. I mean, if the tree growing and planting cycle is really sustainable for constructions, especially people on the earth are so much, and the constructions are very fast, but the tree growing takes too much time. I think
Yeah, very good question. I think I understand what you want to know. So, of course, if you have one little forest and you want to build 100,000 houses, you cut down all the trees, and then your trees are gone, and you have to wait for another 50 years. That doesn't work in let's say in balance with nature. So the example I gave from Sweden, they have 40 million hectares of forest, and only the growth each year of those trees. So imagine a tree every year gets a little bit thicker. If you would just peel off all this wood that in 1 year is growing onto all these trees that they have, you can build 5 million houses. So on average, a forest takes about 50, 60 years to be fully grown. So in essence, only in Sweden, it's just one country, they produce, let's say, 50 times 5 million houses in 50 years. This is way more than they need. And that's important for nature, because we don't want to take down all their forest for building buildings. So you have to do a calculation, how many hectares of forest do I need, or how many square kilometers of forest do I need to be able to produce a decent amount of houses that we need. So in Sweden, it's much more than all the houses that they need anyway, so they don't have to chop down their forest. There's a lot of, let's say, still natural forests around, but it's really about this balance. If you want to cut down a certain area of forest in Sweden, you have to make a sustainable plan and hand that in with the government on what you want to cut and how you're going to replant, and make sure that all the animals that live in the forest can maintain their habitat. So if you cut down a certain area, of course, that is then a naked spot, it's empty. So for birds, for mice, for all kinds of animals that live in the forest, they miss their forest. So they have to be able to migrate to another area, which doesn't have to be, it shouldn't be too far away. Much more complex is even, for instance, elk and deer, which are in the forest. They have to make special corridors between areas that are cut down, so that these animals can still survive in the forest, be within the protectiveness of the trees. So the Swedish government is really strict on, let's say, the balance between the industry and the nature. And they do this for 40 years. And so they showed over the past 40 years that it's really possible to do this in a sensible way, together with nature rather than against. So yeah, if you look to the big forests in Brazil, where they cut down all the big trees and then make big soya fields or put cows in there, that is really horrible. But that's the trees there are not cut down because somebody wants to make houses out of it. No, they're just cut down because having cows or making soya just brings in more money. So it's really about the strategy of having a balance. The earth is more than big enough to have enough trees to make all our structures out of wood. That's really not the issue. The issue is we should maintain the forests that we have and work with them in balance in nature, so that we don't lose all the forest, but at least have it on the, let's say, in the same amount as we do at this moment.
Thank you so much for your answer.
Okay, you're welcome.
If anyone wants to ask a question, you can.
Just may I say something about the presentation? Just a little thing. I'm so sorry about it, but thank you for your presentation. It's not about that, but my how can I say, my family includes biologists, and when I talk with them, they don't say the trees don't stop product any oxygen. They always continue to product. But in the presentation, you wrote trees stops when they be mature.
Mature, yeah. Yeah, as far as my knowledge goes, it's like this. So if a tree grows in its younger years, just like humans, they grow fastest when they're young. And they take on the most CO2 when they grow. Just like we gain a lot of weight between, let's say, the age of 0 and 20, we grow physically the most. Basically, if you take care of your body a little bit, the weight that you have when you're 20, you should have when you're 70. Only when you eat unhealthy stuff, then you get fat, but that's not good. But that's a different topic. The same thing goes for trees. So it's not said that they don't produce oxygen. They take in a lot less CO2 when they are mature. And if we replace them for a younger tree, then that younger tree can again have this grow moment. So the young tree takes on a lot more CO2 than the big tree. That's why the big tree needs to grow. But there's also another thing that I explained in my presentation. Trees don't grow forever. At a certain moment when they're big, they tumble over and then they're gone. Some trees can grow up to 60 years. Some trees can grow 150 years. In America, there are trees that can grow for 2,000 years, but this is really exceptional. Most trees are done growing and done living when they're 60, just like humans, and then they tumble over and start rotting. And that's a very good thing. There's nothing wrong with that because it's the cycle of nature. But it's really a misperception of biologic people and others that trees just grow forever, and it is a linear process. It's not a linear process, and it's really a circular process of trees growing, dying, and new trees growing again. And the only thing that we try to do is when the tree is fully grown, we take it out of the forest before it tumbles over and make place for a new tree to grow. The bad thing that you can do if you take out the tree is make it into a field for cows, because then you don't replace one tree by a younger tree. And that's essential in my story. Every grown tree has to be replaced by a new tree, make space for a new tree to grow, and then you get the absorption of the CO2 to a maximum, and we can build wooden buildings.
Yeah, thank you so much.
Okay, you're welcome.
Buse, if you want to ask your question.
Yes, thank you. Thank you for the presentation, Boris. I'm from Middle East Technical University, neighbor to the Bilkent University. And I want to ask about the future of this usage of natural material, because even though we nowadays, after the pandemic, go back to the nature, we try to go back to the nature, but humans have tendencies to forget the crisis. So you mentioned at the beginning of your presentation about the low-tech sustainability and high-tech sustainability. What do you think about the future of those materials? And I mean, after the 50 years and even in the 22nd century, can those survive?
I'm not sure can you explain your question one more time specifically?
You mentioned the high-tech sustainable buildings and low-tech sustainable buildings. I mean, we use many technological advancements to make the buildings more sustainable, and we build cities like Mastar City, for instance, but we don't see there any bamboos or woods. So in our studio, in this term, we are working on the future scenarios. So that's why I'm asking the future of those materials, because, for instance, the modular structures with the prefabricated woods are very easy to assemble on the site. But do you believe that they can survive after 100 years later?
That is, hopefully I understand it better now. That's a complex question. So first of all, I would say buildings on average survive about 50 years at the moment. So as I said earlier in my presentation, we don't build colosseums all day long that survive for 2000 years. It's really, we put up a building. I see it in Holland. We even demolish buildings after 30 years because they're too small or too much in the way or anything. But certainly after 50, 70 years, a lot of, let's say, our building traditions, our the way we have our luxury is different. We want bigger houses than we had 70 years ago. So there's a lot of demolition and restructuring going on, and we really should anticipate in that. So it's not the question what happens with my building after 100 years, can it still survive? It's the question, what are you going to do with your building materials after 100 years, after you have to change your building because we as humans improved and our demands improve. So we don't want to live in a building of 100 years. We want better insulation, we want bigger windows, we want bigger spaces. That all changed. And then my question to you is, what are you going to do with your building material if you have to do these changes? And then so we both go in 100 years to a building area. I build my wooden building. I bring my chainsaw and I chop down the building into pieces that I can use for a new building, or if I don't want a new building, I can just make a nice fire out of it. You come to your building and there's a pile of concrete. What you are going to do with it? So basically the question should be the other way around. It's not my problem. I have an easy problem with my wooden building, but people with concrete buildings, they have difficult problems in 100 years.
Yes, I see the misunderstanding. Sorry for that. I will try to make it more clear. I mean, I don't ask the what will be the buildings constructed with natural materials in 100 years. I'm asking the understanding will survive or not. I mean, in the year 2080, will people still try to create buildings with natural materials?
We have to, because we run out of other building materials. So in 50 years, we cannot make concrete buildings anymore because we used all our resources for the sand and the other ingredients that we need for concrete. We just run out. And because that's a linear process and we don't have good sand anymore to make the concrete, we're stuck. Using wood is a lot more efficient because it keeps regrowing itself. So in 500 years, we still have trees, but we don't have concrete.
Okay, thank you. That was the answer.
I can add something to that. Can you hear me?
Yes.
Oh, Sander speaking. Last week, coincidentally, I was looking into a project of a colleague. He's designing a pavilion in Masdar City, and you just mentioned Masdar City. I think it's an evolution, and also Masdar City is already 10 years old from the first plans. And they asked us last week, or they asked my colleague last week, to change from metal to wood. It was a big shading system on top of the pavilion, and he made it in a very efficient aluminium. Also because that was the preference of in the project. But last week they asked him to do one final big change to the pavilion, and that was to take out the aluminium and to use wooden panels. So I think also there is evolution, and they will change to the logic that Boris just explained. So it's a very interesting period. There are a lot of things changing, transition period, also in the building architecture.
Thank you, Onat.
Okay, one last question, and then we will pass to Sander. And
Yes.
maybe for the last question and question answers part, we can just, if you have any other questions, maybe you can just ask for it. Do you have any other questions? Just for one last question.
Baran, I think you were waiting, so if you
Yeah.
want.
Thank you. So how much does the wood expand or shrink due to the temperature changes? And have you ever came up with a problem when you were building the structure or maintaining the structure?
Yes, a very intelligent question. It requires a little bit of wood knowledge to, I think, to have this question, because yes, wood is a nature material. As I explained, it can take in moist and can release moist at a different moment, but with that it starts to increase and decrease in scale. If you use solid wood, so you have a tree, you just cut the four corners and dry it properly and then make a building out of it, that wood is still expanding into a structure, and that's complicated for building buildings and maintaining buildings. The interesting thing though with, for instance, using CLT, this cross-laminated timber structures, is that they get mounted in on average 7 layers. There are 9 layers and 5-layer systems, but they're on average there's 7 layers of wood glued. How do I explain that? In a rotated manner. So first of all, you have the wood. If you can see my hands, the first layer is this, and then the next layer is this, and then the third layer is this, and the next layer is that. So that's why it's called cross-laminated. So it's always rotated on top of each other. So if the wood expands mostly only in one direction, in the long direction of the tree. So the tree grows, let's say, in this direction. That's how it can expand. In this direction, the tree cannot expand, almost nothing. So by making these laminated systems, making cross-laminated structures, they are sort of eliminating the possibility for the wood to expand in this one direction, because the other direction keeps it together. And therefore you see in these CLT constructions that there is hardly any movement, not more than in a concrete structure, in your walls and your ceilings. So in that sense, you don't have to take extra measurements for expanding the wood.
Thank you.
You're welcome. Okay, Sander, your turn.
Yeah, you talked enough.
Yeah, I think I'm done talking.
Boris,
Great.
thank you for your presentation and answering the question.
Thank you, Sander.
Okay, shall I try to share my screen? Can everybody see it? Yes?
Exactly.
Yes.
Great. Well, a short introduction from my side. Mirck Architecture, so my own name. And today we talk about design process. I added 2 words with daylight to give a completely different presentation than Boris just did. Boris and I are related in architecture. But I think I knew what Boris was going to tell, so I chose something completely different. My office started in 2003, and we did more or less 17 buildings in 17 years. So slow architecture, you could call it. We are a team of around 4 people, a balanced team of architects and building experts. It started all with Daylight House 1, and it was nominated for a Daylight Award in Holland. And so I knew I had something interesting with daylight in architecture. A few years later, I had an exhibition and lecture at the METU in Ankara. It was really good fun, so thanks Onat for that. And maybe some people can remember it. And now 10 years later, we have a sort of a reunion here online, and my Daylight House 3 is currently nominated for the Daylight Award in Holland. And I think in February or so, I will know if I win or not. But design process with daylight. Oh, here's some images from my office. And here you see a picture from the outside during an exposition about daylight in architecture. It was last year. And next year it will be in Haarlem, city next to Amsterdam. Here you see the nice poster. And yeah, it started with, well, literally the enlightenment, I think, for me, for myself during my study in Delft, but also I think with the world in the 17th century, when we started to realize that the sun was the center of our solar system and not the Earth. And we started to take science seriously above, for example, faith. And it was important because it gave a lot of innovations to the world, and until today. But sometimes it's not on the first place. Sometimes it's difficult to get enough evidence to change the world in the logic way, in the scientific logic way, like we just talked about the climate change and building with wood. It's very complicated to get it done at the moment, for example, in Holland. It's going well because it's logic, and the logic will overcome. And the same is for example, with daylight. I think we always built with daylight. I mean, we were outside people, like Boris told us, and but we went inside. And first we had the dark ages, and we made castles to be safe inside. But then after a while, we realized that we liked air and light, and we started to make beautiful churches with a lot of light falling in. But then I think around 100 years ago, we did some good inventions like the artificial light, the light bulb. And we realized that we could make enough light inside buildings so that we didn't need the sun anymore. And especially in America, the very thick skyscraper towers emerged, and also the sick building syndrome. So people started to feel not so good inside, deep inside buildings the whole day. And you're looking at two bars of colors. Left, you see the light outside. Lux is a measurement of how much light there is. Outside, it can go from 10,000 to 100,000, very dynamic. And when you're inside a building, you're in the only 1% of that part. So inside a building, you only have 1,000 lux maximum, and it goes all the way down. And on the right side, I'm sorry, it's Dutch, but there you see what it means, these colors going from 0 to 1,000 inside. And well, in blue and green, you can't do much. In yellow, you can start doing your work and feeling okay. And when it hits the red, you feel better, you feel normal. Your skin starts to reacting to the light it gets. It becomes active instead of passive. You could say that below yellow, you're sleeping. And a lot of people are working in green and blue conditions. So you are more or less, your body thinks you're sleeping while you're working. So for me, this is important, an important starting point, like a scientific starting point, also for my architecture. So I try to incorporate science into better spaces. This is one of the projects we did in Holland, and it's a university building. Here you see people sitting outside because that's, of course, the best place to be. But also inside, just behind that, that black back house, we have a big college lecture hall. And on the left, you see the foyer of this lecture hall. And we used both the courtyards of the old monumental buildings because more than 100 years ago, they designed buildings with a lot of daylight and fresh air. But in the last century, because of the light bulbs, we started to close them and put a lot of artificial light in it and use every square meter inside these complexes. So now I think we are back again in a period that we starting to appreciate light and the positive effects it has. So we open up the buildings, the old building structures again. So this entrance of this lecture hall has a lot of daylight falling in, and the people like it very much. It's their most favorite lecture hall in Leiden, in the city of Leiden. I will show this in the design process in 3 houses. So the Daylight House 1 I mentioned before, and then 2 and then 3. And I'll show especially a lot about the last house, Daylight House 3, and focus on the design process, because that's what we're talking about today. So the influence of daylight in the design process. Well, this was my first house. Fortunately, I got an assignment for a huge house, and it actually got built as well. And I told this client, if you want to make a very large 1-story building, it's too dark, so you must open the roof. And he liked the idea, and in the end, the roof was completely open, and the house was, well, a big surprise. So if you went inside, it was an extremely high daylight level. Here you see the house, the way we start designing. You take the location of the plot and you put on top the way the sun goes. In this case, in Holland, the longest day and the shortest day. And you can more or less feel what's in between. And you get a feeling what the sun will do with this house you're designing. Here, the scheme of the house, with the high summer sun and the low winter sun, and the blue arrows are the diffuse light from the zenith, from the north side, that falls in indirectly. And the colors I just talked about, you see them here in the floor plan. A lot of daylight inside this house, because a normal house is blue-green at best. And here you see that we hit a lot of yellow and red. Here a picture from the inside the kitchen space. And well, sometimes some things are difficult to show on photographs, but the light level is extremely high in this house. So it gives a strange and positive feeling. Well, the first house was an experiment because it was my first project as an architect. The second house became a research because we knew already some things, and we tried to improve them in the second house. Also because the client asked for it. Here you see me on top of the house when it was finished. Then you get an impression of the end result. It's a cube, a wooden cube. We used the same wood for everything. The window frames, the load-bearing structure, the facade elements, and so forth. Again, the same side picture with the sun going around the whole year. This was a house of 3 stories instead of 1. And here we tried to, again, bring as much diffuse light from the north inside the house. Not in the bedroom, but in the other spaces. And on the southwest side, on the left, we try to give some shelter from the direct sun. So not on the terrace, but in the living room. Here you see the scheme again with the colors. We try to use this daylight visualizer in the early stages, and we continue that until we know it's good. And here you see a lot of light coming in on the north side with a sort of a winter garden that also Boris is showing in Amsterdam. And via voids and staircases, it goes down into the living downstairs, where you get a combination of direct sunlight and diffuse light from the north. And here's some pictures from the house inside. So right, you see it's below, you see the living room looking into the garden. If you take the stairs up, you will see the left picture, the split level and the winter garden on top. Well, then the big exam, because after 12 years, you should know how to do it. So this client, like the other 2, let's say he was impressed by the first 2 houses you just saw, and he asked me to do the same, more or less, on a different plot with a different budget. There was some more money to spend. Well, here you see the house. It was a very delicate site, nature reserve, and finally we managed to design a house with corten steel so that it would fit in the surroundings. Also, the volume is quite low, but it also has a floor, a basement more or less inside the ground, inside the dike. This was a plot, and you see the white old house. It was there. We could demolish it. It was almost falling apart. We could demolish it and put a new house there. Well, if you have a chance during a design process, try to go there and sleep there and eat there and do everything. That's a perfect way to start and to feel the site. So not only in SketchUp, but also in real life. What is the sun doing there? What is the climate doing there? What's the wind doing there? How do you feel over there when you wake up, when you go to bed? This client was fond of the great views, and after a while we were there with him, and we put poles inside the site. For the bedroom, he wanted to look to the lake. From the kitchen, he wanted to look to the north, to the stream, to the landscape. Well, those 5 lines, they came out. It should be like that. But then we told him, it's as important to consider the sun also for your views and the use of spaces. If the sun falls in, and when does the sun fall in? So we projected this image, these two images on top of each other, and we started the design process with him. You also see the panorama slide, the half circle. That was the most beautiful view, and that became also the most important element of this design. Is working and living space should have this 180 degrees panorama. Well, to show you also some bold SketchUp images, it's simply how we started. Here you can see some things from Daylight House 1. And we tried different roofs. After the first one, you wanted to have different spaces, so we made different roofs. You wanted to, we decided to open up the house to the north, again, to get a lot of light from the north and to get as much light inside of the house, also on the south side, with the big panorama that's on the right. So you have to block light against glare and blinding with cantilevers, for example. But at the same time, you can let the diffuse light from the north penetrate the building very deeply. Here's some sketches. It's not only SketchUp, but also the pencil still, and here he could choose out of 6 options at that time, and he chose the one with the black square around it, so the volume that was opening to the north. And I will quickly take another few steps to show you the way such a design evolves. I show you the 3Ds, but of course there was a lot of sketching, a lot of being there and putting the poles next to each other on different levels. Here you see that it's really opening up, sketching the structure. Don't forget the construction, of course. And here it's finding its place together with terraces, reeds in the water. The chimney is moving from left to right. And here we're almost there. With the client, we used this same SketchUp really every time we met him, and we also sent him things and explained to him how to walk through it, and even to use the VR, the Oculus, to be inside and feel things, explaining also the technical things, the daylight visualizer. We explained it to him, and everything was part of the final design. And here you see the woonkamer, that's the living working area. So it has glass completely in this 180 panorama. You will see a picture after a few minutes. And on the north side, you see the kitchen and the breakfast area with the perfect light in the morning coming from, it starts almost here and it falls in, the blue light. And in the evening, when the sun is all the way here, the red light falls into his bedroom, or it hits the interior of the living. Well, some text also to again think about daylight. It's fast and irregular. I really find it fascinating. Our eyes are very good in adapting to daylight, to changes in daylight, and architecture can help. So we can help the eyes doing it even better than we already do it, and it's very dynamic because it changes continuously. If there is a cloud in front of the sun, it's a completely different atmosphere than just before when the cloud was not there. But at the same time, you have the slow and regular sun, the daily rhythm. And we really feel better if we are supported in that, so that we get the blue light in the morning and the red light in the evening. And also the seasonal change. So that's the very slow, the year-round changing. It has a big impact on the interiors. It's something that you don't think about every time, and I'll show it with some diagrams as well. So this is more or less the same scheme we always use in the section to explain the building. So here again, a lot of diffuse light from the north and more or less blocking the light from the south. The same, but then in the daylight visualizer to show it really. Well, this one at the moment it doesn't work, but you can make it moving so that you can see what happens during the day. So then you have the dynamics in also a feeling of the dynamics. And I wanted to show this one. We call it the light beat. Here you see the floor plan of the house, and it's shown every hour of the year. And then we took three, more or less one shot every month of a day. And you see the whole day. Of course, the night is blue because there's no light. But then you see that for example, in summertime, you have 2 times more light than in wintertime. And so you are sometimes really also designing for the 2 extremes. So what happens in the summer and what happens in the winter, it's completely different. Your house or your building is performing completely different. And you can really gain some qualities there. Here is a zoom in, and then you see the 6 p.m. jumping. That's because in Holland we have winter and summertime. I don't know if that's if in Turkey they're also crazy to do that, but in Holland we put the clock 1 hour earlier and then 1 hour later, a couple of months later. But that's the jump in that 6 p.m. timeline. But here you see, you can ask yourself, for example, for this house, if I use it mostly in the morning and in the afternoon, when I go to work or when I come back from something, what's happening then? Sometimes it's completely different than a few months later. And maybe the house should adapt to both those periods, or all the periods. And I'm sorry?
Mikrofonunuzu kapatabilir misiniz?
Okay,
sorry, Sander, you can
problem.
continue. Sorry.
No problem. So the light beat, it's incredible to have a look at it and to understand your building or your location better. Here you see the roof light. It's the museum rooster, we call it, raster. And it blocks all the hot direct sun, and it only lets in the diffuse northern light. Also the heat is on the outside. And here you see the difference between making a skylight or not in this house. And so left you see it's more or less a unity now with the light levels. And on the right, you can see there are 2 different areas. Well, here a picture from the living room. You see on top, you see the skylight bringing a lot of daylight in. And on the left, you see behind, you see the kitchen light. And here's the sun going down. The basement is made of concrete. And the structure on top, it's made of steel because we have a preference for wood, but the demands of the clients and the big openings in the building made it impossible to make this building in wood. This is what I call the climax. When your building is there, the volumes, the spaces of your buildings are there. Still, you have to work almost a year to get everything closed and get the right temperature and things like that. But the finishings. But this is the moment that you all of a sudden you feel the building. It's really a climax. And well, here looking north, So that here you see the picture at the climax. You already feel where the building is going. And the next picture is the final result with the finishings and all the glass inside. And here's some pictures of the final building. Well, the influence of daylight, unconsciously we monitor it continuously. We anticipate on it, our brain, but we almost not think about it, maybe because it's always there. You get used to it and you think it's okay, but it can be better. Yeah? It will enlarge our view on nature as well and architecture. And the second one, if we explore it, I think we can make better architecture. It's very complicated, but exchange with biology and physics, it can really enhance the final result. This was the house that was there. It was well, a nice house. Everybody in the neighborhood liked the house, and they thought it was a pity that it had to disappear, but was almost falling apart. But it was a white house, and it was the client wanted an English house, and he got it 100 years ago. But now, with all this daylight influence, it became this house, and I think it's a big improvement, of course. I want to end this house presentation with the finding that was most made the biggest impression on me, and it was that the daylight inside the house intensified the views. So the view was most important for the client, and we could make this view better by letting a lot of daylight inside the house. And that's because you understand your view better if you experience the same light inside. The same goes for you understand your light inside better because you look at the landscape that is giving this light. So I give it the name a room in a view. So this is the view of the room. This is the landscape, and it is more or less caught inside in the room, the view in the room in the view. Well, to conclude the design process again, I always try to find balance between the client and myself, between the builder and myself. The cosmos in the interior we just talked about, grip and chaos, what I call it. I think it's so complicated that you try to find a balance on what you can comprehend and what you can design, but you also have to let go. You have to be confident that also chaos will always be a part of your design. And underneath, location and user, physics and aesthetics, brightness and glare, if you look at light, for example, and you can continue. So don't be afraid and try to let all these aspects influence your architecture. To end my presentation, I show you a building, another house that's just a few hundred meters away from Daylight House 3. To show the influence of a client, because it's the same architect, but a completely different house. It's a reed roof next to a reed area. Here you see it from the inside. It's also completely CLT, cross-laminated timber, and special reed roof on top. But I must say it is, for me, I see a lot of parallels with the house that you just saw. But of course, it's completely different. It both has a lot of impact, the daylight. Again, for example, this cut in the house is facing north. and it gives this house also a very high level of daylight inside. And the final slide is Daylight House 5, and it will be built next year. And well, here you also see a lot of glass, a lot of wood, and a lot of daylight. So here I wanted to conclude my my presentation, and I hope it is a good combination with the presentation you just had before, Boris. Thank you.
We thank you, Sander. It was great.
Thank you, Sander.
You're welcome.
I would like to say capturing the landscape. Actually, it's like it's unbelievable from both from the outside but also from the inside. And the landscape is super nice. So you don't need any artwork at all because it's already the artwork. But thanks a lot. So, is there anyone who wants to ask questions for Sander? No, Jansu, we are looking at you.
I have a question actually.
Hocam, I didn't really receive any questions, but I think Doğa has one right now. And if they do have questions, we told them they could just ask Sander or Boris directly. So I think it will just go like that. And we'll start with Doğa, if that's okay.
Okay, of course, Doğa.
I have a question for Mirck, and thank you so much for your presentation. I wanted to ask, how do you conduct the light analysis in different stages of the project? And if there are any special softwares, can you mention them? Thank you.
It was very soft. I couldn't hear the question. Sorry. Could somebody repeat it?
Is it better now?
Yeah, much better, much better.
I would like to ask, how do you conduct the light analysis in different stages of the project? And if there are any special softwares, can you mention them? Thank you.
Yeah, there's a lot of software, also very complicated scientific software, but there's also very easy free software, and it's the Velux visualizer. So the company Velux, V-E-L-U-X, it's a company that makes roof lights, but they also have a sort of an organization that supports all kind of daylight in architecture from Copenhagen. And they also have this free program. So you can find it at Velux Visualizer. And that's the program that we use. So you can very easily put your 3D model inside this visualizer any time of the design process, any time of the year. And you can, everything I showed you, I showed you fixed images, but we often use moving images. You can make anything. And last week I saw some presentations at your university, and I see that everybody works very well with 3D modeling. So for you, I think it must be very easy to use.
Thank you.
You're welcome.
I would like to ask a question, if it's okay.
Yes, of course.
It's not about the structure, like what you showed us, but it's more of a general question. How does the client approaches to you, and how do you interact with them?
It's a very good question also for me, because I would like to be found by more clients. Maybe the good answer is that the clients find me because they see a good building that my office made. And of course, that's a difficult one, because one building should be the first one. You must start somewhere. But at the same time, it shows that if you build what you really think is best, and you convince in that aspect, you will find the right clients. You will find clients that that understand this and are convinced by this. And that's the reason that I could take this idea, because now I only showed you the daylight houses. Of course, my office also does different projects, but because I did it this way, I could make now 5 or 6 houses in this with these same qualities and the same developments. So the clients found me by seeing my my buildings, and they got interested by the topic, and also because this topic is almost never mentioned. So especially with Corona now, a lot of people are sitting at home, and every time I present the building or I talk to them, they realize that they are living in a very dark house. And maybe it's different in the Southern Europe and Turkey that you have to block light a little bit more, but still I think people really need the light, and so this is an important topic that was forgotten in the last century, and now gains that is now gaining the same with it's in line with the wood, for example, from the first presentation. Wood is also is having a revival at the moment. It's on the start of the revival, and I think daylight is just behind, but also starting a revival.
I would like to add something actually in here. I think this is called, what we call it, like physical portfolio. People are just going to their neighbors and things, and they say, oh no, I have a house really dark, and then suddenly they're just looking for the architect who does it. But at the same time, with the houses that you share with us, the light, of course, the location of the sun and the things is important, but the usage of material is really important in that case, and I'm really impressed. I'm always impressed with the daylight houses, because it's like the wood and the finishes and the things, because the material is just reflecting the light. So to get this kind of a homogeneous light inside in like this, it's a really hard topic actually. It looks sometimes it looks simple, but it's not, and it's not just the things, but also how it reflects. Even in a space, just like 3 materials or 2 materials will affect each other, and the light will change, and with that change you can be super uncomfortable. So to catch the quality and how it reflects the material, or how it gets the light inside.
For example, in this house, we used also, now you don't see any blinds, but of course they are there. For some periods of in the year, you really need something to have no glare. And the blinds we have, like Luxaflex, they come out of the ceiling, but they can also, for example, block the reflecting light in the lake over there. So we also thought maybe the light sometimes comes from underneath, and you can put the Luxaflex in the other direction to also block that light and still get some light from the sky. So you can, it's just smart thinking. It's just putting some extra effort in it. It's scientifically almost, but you can make that combination. You can make architecture richer to think about those topics as well.
Yeah, but also, for example, it's like visiting the site thousands of times, because of course we can use some programs or something like this that to do simulations about the lighting or something like this. But at the end, when you go there, you feel, then you just suddenly, because all these programs, what we use, cannot just calculate the reflection from the lake.
No.
And when you see it, then for example, you have to visit. And when you do it, sometimes it's really tough. And when you finish something, when you go there, when you finish the project, maybe you think that okay, now it's complete. But when you go there and when you every day it can also just make you feel like change something, and I'm sure it will change during the process. So when you design it, not just an architect, maybe this is one of the big faults of the architects. They just do the design and they just send it to the contractor, and then the contractor started constructing it, and they just follow the process like maybe six weeks. And 6 weeks or something like this, and they miss many opportunities. And also maybe sometimes they just get away from the concept if you're dealing with light, because light that you cannot just even all the data that you just get from everything, it's hard to control. It's hard to design something like this, and I'm really impressed. Also, for example, with the Core-10, I have also allowed the material. It's a soft steel, and it's super nice. And even with the red blossoms of the trees, it fits in the nature. So people, what I really wanted to say is, of course, with the light, but the material usage and the things, it's the expertise. And thank you very much for the presentation, because it's when I look at it, I just said, okay, I want to live in this house because it's like a fairy tale house because of the landscape and the colors, and even the trees and the landscape is just in it. So it's perfect. Sometimes people are just buying artworks to just say to add some colors in their houses, even the lights and the things. And in that kind of a house, I don't know where to put the TV, because I don't want to put anything on it. I just maybe I can sit on the ground, because sometimes it's all these kind of things like the view and the things, you don't want to put any furniture in it. Of course, you say, okay, I want to, you just, maybe your client just asked for like, okay, we have some guests, we need a guest room, and when you enter in, I'm not going to take anyone into this house. So you can say it. But thanks a lot.
You will. You see in this picture, you see in the floor, you see some squares, and those are pots where he can put his computer in, or his box, or his anything. So he was not already moved in, but he's going to use this space flexibly. Also, during that, he can change his interior completely for another season. But he also really wants to live with nature, with the seasons. And Onat, you really should stop by next year or so, because on the left side, you just cannot see it, but there's a really big garden, and it's designed by Piet Oudolf. It's a very famous landscape designer. And I made, 1 month ago, I made some autumn pictures, and it's really incredible. It's so beautiful that you don't need a television. Maybe when it's dark outside, but it's too beautiful to look inside.
Yeah, but I hope next year we can visit there after this. Maybe this COVID thing is over a little bit, so we can visit there in this with the landscape.
Yeah.
We have some questions for Sander, if that's okay.
No, it's not okay. We are talking now. I'm sorry. I'm not going to accept any questions. And it's of course.
Okay, then we can mute ourselves and go.
No, please, because sometimes it's a little bit tough, and with you're a generation that you're really brave in the behind the computer, but when you're faced with the people, then you're getting a little bit shy. When you're collecting your questions, I was trying to. I really miss Sander. At the same time, I'm trying to get a little bit chat. So that's fine. Okay. Who wants to ask the question?
Sadık wants to ask, but I'm gonna ask it for him. While designing residential spaces, do you feel confident to play with the light, or is it easier when it's in public spaces?
The question is if it's easier to design a public space instead of a house?
No, is it easier to utilize daylight in a residential space or a public space? And what are like the requirements for it, kind of?
Well,
How do
it
you
really,
mean the public space?
yeah, it really depends on the function, of course, and that if you can convince a client that that daylight must have a lot of influence. Fortunately, it works with these houses that they want a lot of daylight. For public spaces, it should be the same, of course. If people are using it for a long time every day, I would advise to also bring a lot of daylight inside. Maybe a little bit like this lecture hall, for example, I showed in the beginning. It's now the most popular lecture hall in that city, at that university. Well, that shows the quality it can give, and that it's worth for a lot of functions. And well, the adjustment, for example, in this college, in this lecture hall, it was very important that it could always be manipulated, because of course they used beamers, or they had a lot of people or only few people. There were all kinds of reasons also to not let daylight in. That's also the main reason that most lecture halls don't have daylight. But if you, again, think smart and put a lot of thinking in it, it is possible. Of course, it's possible. And in this case, you can easily use a screen to blind the daylight if you really don't need it. But for, I think, 90% of the time they use this lecture hall, they keep it open because everybody wants it. So it really only gets closed if that's the only option. So, yeah, I think with smart thinking, you can make any space with a lot of daylight if the function can profit from that. As of course, some functions like well, you can imagine some functions that don't need any daylight, but most public spaces do.
Thank you. Thank you, Sander.
Can I ask a question?
Kevin?
Of course.
I want to ask about the context of the projects. The projects you showed were mainly in a rural context. But when we think of Turkey and especially Ankara, most of the projects that we design in our architectural studios are in an urban context, actually. So how would your approaches change when the projects would be located in an urban context?
Well, the most light comes from above you, from the zenith, and there's as much light coming from the north as from the south, to give you an impression. But most light comes from above you. So this roof light in this house gives the biggest volume of daylight, and almost every building has light above. There are not many buildings with a building on top of it. So of course, when there are big buildings around you, you will have a little bit less light, but you can calculate it as well. And maybe that could be a reason to use more roof lights when you have a lot of high buildings next to you. But also in cities, I think you can still get more than enough light from the sky above you.
Mm-hmm. Okay.
And of course, it's true that when you have a lot of floors in your building, like the one house I showed, it's 3 layers, and we did some. We designed a building block for 5 layers, also with daylight housing, and then with patios going all the way in. Maybe a little bit like they used to do in the more than a century ago. They made these courtyards in the old buildings, the ones I reopened with the lecture hall. you must think of those kind of smart openings in the building when you have a lot of stories, when you have a lot of floors on top of each other. And you really need voids and patios. Yeah.
Okay, thank you. If anyone wants to ask a question, you can unmute yourself or you can write to us so that we can ask.
I think there isn't any more questions.
I had a question, if that's possible.
Huh.
So thank you for your presentation, and my question is very direct. Like, you're basing your designs on data, like daylight. So how hard it is to go from smart design to a unique design? How do you combine them? Is it difficult? Based on your experience,
the client and the context, the location can make it unique when you use data. And that's a starting point. And of course, you yourself as the designer. So the client and the designer have ideas and preferences. You have the site that always has a lot of gives you inspiration, and then you can start with the data. Then the science and the biology, it's there. So I see it as a very fascinating and inspirational starting point to see well, yourself as last, but for first the client and the context, the location, and science, and yourself. Those four as a great starting point, and it will always be unique because only the science is not unique, but the other three are. Is that a good answer?
Thank you, thank you.
Yeah. And then maybe I can add that you just have to try and to be confident that you will get to something unique. Like my first house, it was an experiment, and I just thought I think this is good. My client, I convinced my client. I have science on my back, and the first house didn't even have a great location, so I had to do it with only the client, me, and science. But yeah, it will work.
Well, Sander, can I ask a question with the image? How do you just without daylight, for example, at night? Where is the light in this picture? It's super nice because the roof, just two materials and the daylight. But what about at night?
Well, I could sleep here a couple of nights after it was finished. It was a great gift from the client. I was there 2 times, a couple of nights, and you can close the house with screens and curtains and the blinds, the Luxflex. But
no, I mean at night, because I don't see any lighting. Maybe did you hide it on the ground or the floor, or it's just for the lighting you use?
No, but of course we have lights. You see in the roof, you see all little spots. They're there. Also, we calculated everything that on this level, he could make any light levels, artificial light levels he needed for his work or his atmosphere. But in the end, I wanted to tell you that when I was sleeping there, we didn't use anything at all because at night, if it's dark inside, you get a really great view of the landscape outside. So maybe we were lucky that there was a full moon or something, but it was as beautiful in daytime as in nighttime. But you can close the house, you can put lights on every spot you like.
Yeah, but I think it's the most important thing is space is like it's wonderful because these kind of electrical even the cables and the things, it's totally like super nice. So that's why even I didn't see it, and I'm sure from the outside they will look like stars inside when you just open the lights. Even at night, when you're walking in the landscape and when you look at it, these small and really hidden light pieces are like stars.
Yeah, here you see it a little bit. So at night you see the inside of the volume, but it's also yeah, special.
Yeah. Great. Any more questions?
I have a question, actually.
Oh. Cansu?
Yeah.
No, İlayda.
İlayda. Seni bekliyoruz. Pardon.
So, for example, in the Mediterranean coast of Turkey, in summer days, the air is just, the temperature is just too high that we have to close the windows and we just live with air conditioner. So I wanted to ask you what would your approach would be in your design if you designed in a hot temperature location?
Yeah, you should take care a lot more the blocking of the direct sun. That's the most important one. Next year in Holland, starting the 1st of January, we get stronger rules also to do it in Holland, because we are isolating or insulating the buildings so well that they also heat up too much in summertime. So the new rules in Holland are also to think about shading and blinding. But if you calculate, if you do some research, it's still possible to use a lot of glass if you use it in the right way. So not on the south side or with the big cantilever. Well, in this case, we use triple glass, but that's of course quite expensive. But the other house I showed you was with double glass, so it's still possible. But you must be careful and do some calculations and take yeah, it's nature. In some areas it's hotter than others, and we must anticipate on it. But it is possible. It still is possible, also in the hotter climates. And one of the beautiful things, of course, that also Boris showed, is to use nature literally. So to use plants. In summertime, they will grow and they will give you a lot of shading in the facades, for example. And in wintertime, they let through the daylight. But that's again a beautiful example of designing with nature.
Hear, hear.
Well,
if you have any other questions, please just because you can also ask for both presentations, and then we can conclude, because it was super nice. But I don't. They had a huge party yesterday, I think, Sander and Boris, and now they can be a little bit tired. So if you have any further questions, please just ask it, and then for the rest of the Sunday, maybe they can rest a little bit.
I can actually, I can ask some of the questions that some of our participants wrote us. One is from Ahmed. I'll just read the question from start. Firstly, thank you for your presentation. It was incredibly inspiring for me. I have a question for you about detailed design of buildings that are built with wood. Do you design specific details like connections of beams and columns, plumbings, isolation solutions, etc.? An architect or as an architect, or do you use wood production firms standard details usually? Thank you. It's a long question. I can repeat it if you like.
You want to answer that, Sander, or should I?
Doe jij maar even een stukje, Boris.
Okay. Sander is tired. Yes, first of all, to design with wood, it's extremely important to integrate everything in a design stage, much more than if you build with these stone blocks or with concrete. The way we work in our building industry, for instance, they put up these stone blocks, and then installation guys come in and they start making holes in the wall to implement all their the electricity stuff. With wood, this is impossible. You have to pre-think. And that is complicated for stupid building companies. And you see that companies that build with wood are used to do engineering on forehand together with the designers. So at in an early stage, we get really closely involved with super detailed design, all connections, all wood connections, all steel that goes into the wood to make the strong connections, but also all installation, all electricity, all these things should be pre-thought of during design. Then in the factory, it gets all made automatically with CNC machines. They make the provisions at all right places. So you end up really with a mountable, let's say, more like a Lego-like thing on the side that you really just have to assemble. So it's an important question, an important thing to realize also, that this is really changing at least our Dutch building method dramatically, because it really requires from all people to get involved. We don't do ourselves these sort of like production drawings. So we do general detail drawings of all our designs, but production drawings is one level on. But really designing in 3D programs, also for, let's say, production drawings, is for wood really important. So we see already a transition for the past 10 years generally in our building construction, that's much more done with 3D programs. For wood, this is absolutely crucial. So we ourselves also switched, for instance, from AutoCAD more like to Archicad, because that's really a permanent 3D design program that is necessary to design and be able to build in a more sensible way with wood.
Okay, thank you.
So I think I would like to conclude the questions answers part, but Sander or Boris, do you want to give any advice or suggestions about for the new young students and maybe young architects, because then now the time is changing, and also our habits are changing, and you have the things you also experiment many things. But in the future, for these young architects, what do you have any suggestions or anything to say? Not maybe suggestions, but something to say for the future to change the architecture and maybe the society with the behaviors.
Yeah, well, my message is fairly simple. I think the Earth is seriously under attack by the humans. We are with too many humans on this Earth, and because we don't want to kill each other, we have to live together with these 7-8 billion people that we have at the moment. If we want to have a future for the next few hundred years, we have to start working with nature instead of against it. And making buildings and making livable spaces is a crucial factor in that, as is producing our foods, for instance. So we have to make people understand nature better so that we have a chance of surviving with nature. Don't worry about nature. Nature will survive us easily. Even if we destroy it completely, we destroy ourselves within 1,000 years, nature is back. It's been here long before we were, and it will outgrow us easily. So don't worry about nature, but worry about humans. And if we want to survive, we have to work with the only Earth that we have and not against it. And building in sensible way, in balance with nature and with materials from nature, is a crucial factor in that.
Thanks a lot.
And I can add to this apocalyptic view of Boris, the more maybe more practical message that I think that you are very lucky that you live in an era that is changing, in transition, and maybe the building industry is very slow, but because it's so apocalyptic at the moment, even the building industry is changing. So yeah, you saw a lot of interesting things today, and you are working on an interesting university. Be flexible and try to understand the changes at the moment and the logic, just explained by Boris again. And there will be a bright future, I think, for architecture. So work on it, and you're in a very interesting period.
Great, thanks a lot. So Sharon, maybe you can do the talk, so we can go back to our Sundays, maybe for the dinner at least.
Cansu, would you like to start?
Of course. So we would like to thank you, Sander and Boris and Onat Öktem, of course, for being our guests and speaking about these important topics. I think it was inspiring for all of us. It was inspiring for me, at least. Thank you for that, and Sharon can continue.
Thank you for accepting our invitation. We're so honored to host you, and we would like to see you in our next events. Thank you all for coming. Also, our participants, thank you as well for participating in this beautiful event. I think that's all.
Also, for Boris, Sander, and Onat Öktem, we have a little gift for you. One of our friends will send it. Yeah, I think you will like it. It is a sustainable gift, so don't worry about it. Thank you so much.
Thank you so much, yes.
Thank you for having me. I see Zeynep also there suddenly appearing. Hi, Zeynep. Hope you're fine. Okay.
Can I talk? Yes.
Nice
Hi.
for having us.
It was very, very nice to see you.
Great.
There you are.
Good seeing you.
Hi.
Okay. Happy to have you here. Yeah.
Well, good luck with the final presentations as well. And see you next year then.
Have a nice Sunday.
Bye.
Bye-bye.
Bye.
Bye-bye.
Bye-bye.
Bye.